Welcome back. Before I forget, let me start my stopwatch because in one or two videos I've gone up to 28 minutes and that could be boring. So I have to restrict myself whenever possible to about 20-22 minutes max. So I have started this so that I know I don't go wrong. Oh, by the way, my name is Osale Mohana. I have taught A-level maths for a long time, and I'm doing these questions and going over these topics to help you people revise and go over what you learned in school. Right, let's come back. Last time I talked to you about integrating a product. I derived this formula indirectly, and then I've given a new formula here. It's the same as the other one. Instead of dv by dx, I've written v. Remember I told you, you differentiate you integrate dv by dx and substitute. Instead, differentiate u, integrate v, and then substitute. It's the same thing. And I also told you it's shortcut to choosing u and v, the order log, algebraic, trigonometric, exponential, and constant. In exponential, it is e power kx. In trigonometry, it is sine and cos, but not sine squared and cos squared, unless you convert it into double angles. Similarly, not tan and cot, but tan squared and cot squared, because you can write them in terms of sec squared and cosec squared. And e is only e power kx, not e power 1 over x, not e power sine x, not e power minus x squared, not e power root x, e power 2x, e power minus 3x, e power half x, e power a constant times x. Okay? And the first function that comes in the order is from left to right, and the second one is dv by dx. Remember, I went through all this in the last lesson. So I'm taking some examples of applying this. Find integral x cos x plus 2 dx. Look, the logic behind any question, in fact, the question will not say use integration by parts to show that. They do, but rarely. So the only way you do is, first, can I integrate directly? No. Why? There are two functions. Can I use substitution? I can't, because when I differentiate cos, I get sine. When I differentiate x, I get 1. Neither. I can't use substitution. It's not a rational expression. It's not a pure trigonometric function. So I have exhausted all the possibility. Then you say, yeah, it has to be integration by parts. Even though common sense dictates the moment you see two different functions, it is integration by parts. So if I say, write this always, I have an x which is algebraic, I have a cos which is trigonometric, a comes first, t comes next. So u is x, because this is algebraic, that is trigonometric. And dv by dx is cos of x plus 2. So du by dx is 1. V is integral cos of x plus 2 dx equal to sine of x plus 2. See, the reason is, I don't have to write this actually. Why I write it is, there have been occasions when I used to mark papers, students wrote dv by dx, and for some reason, they said v is a derivative of that. I don't know why. I just can't figure out why. That's why, to make it clear, I have written it down. And for the first few questions, I'll write the formula. It's uv minus integral v du by dx. So u is x, v is sine of x plus 2, minus integral v is sine of x plus 2, du by dx is 1, I don't have to write it. Remember, repeat the mixture till the patient dies. That means you keep on working till somehow your integral sign disappears. So x sine x plus 2 Sine of x plus 2 resembles sin x. The extra function is x plus 2. When I differentiate x plus 2, I get 1, which is a constant. So I can apply the formula directly. Sine gives you minus cos. So minus cos x plus 2. When I differentiate x plus 2, I get 1. So for completeness sake, I divide by 1. So it is x sine x plus 2 plus cos of x plus 2 plus c. Right? Very good. Now next, let's take another example. ln x over x squared dx. Which I can write as x power minus 2 ln x dx. This is algebraic, that is log. L comes first, A comes next. So U is ln x. dv by dx is x power minus 2. So du by dx is 1 over x. And v is integral x power minus 2 dx, which is x power minus 1 over minus 1 or minus 1 over x. So it's uv, u is ln x times v is minus 1 over x minus integral v is minus 1 over x, du by dx is 1 over x dx. So it is, remember you can't cancel this x with that x, because one is a log, one is an independent function, plus integral x power minus 2 dx, which gives you minus 1 over x ln x plus x power minus 1 over minus 1. I can remove minus 1 over x common factor. I get ln x plus 1 plus c. Alright? Very good. The third example is integral x cosec squared 2x dx. That's an A, that's a T. Algebraic comes first, T comes next. You always go in that order. So therefore, U is x, dv by dx is cosec squared x. du by dx is 1, v is integral cosec squared x dx, which is minus cot x. So therefore, it's u times v minus integral v times du by dx. So it is minus x cot x plus cot is standard formula. If not, cos over sine, the denominator is sine. When you differentiate sine, you get cos. So therefore, numerator is exact derivative of denominator. So the answer is ln denominator, which is ln sin x plus c. Yeah. Show that integral 3 power x dx equal to 3 power x over ln 3 plus c, and hence find integral x 3 power x dx. That would be a typical 5-6 mark question at A level. I hope this right. No, that's gone. I think I am running out of pens. I have to order pens looks like. Okay. Hope this right. First, look, a power x equals e power x ln a. So therefore 3 power x equal to e power x ln 3. So integral 3 power x dx equals integral e power x ln 3 dx. It resembles the standard formula. ln 3 is a constant, by the way. When you differentiate x ln 3, I get ln 3, which is a constant. So I can apply the formula directly. E power x gives you e power x, so e power x ln 3 gives you e power x ln 3. Then divide your answer by the constant you got on differentiation, which is ln 3, which is 3 power x over ln 3 plus e. Incidentally, that's not a standard formula. If you come across in the exam a power x, 2 power, not e, any other power of x, any other power x, then you have to show the integral first. So I have done that. Now this is LATEC. I have an algebraic one and I have an exponential. So u equals x, dv by dx equals 3 power x. Okay, in the exam, you didn't know how to show that, but you can do that and use it here. You get full marks for part B, you lose all the marks for part A. Don't give up part B just because you don't know how to do part A. You will lost the mark for part A, but you're using part A to do part B. You get full marks for part B if you're correct. So du by dx equals 1. V equals integral 3 power x dx, which is 3 power x over ln 3. So integral x 3 power x dx equal to u v minus integral v du by dx. That is 1 over ln 3 x 3 power x minus 1 over ln 3 integral 3 power x dx. So it is 1 over ln 3 x 3 power x minus 1 over ln 3 whole squared. Please, ln 3 times ln 3 is not ln 9. ln 9 is 2 ln 3, not ln 3 whole squared is ln 3 squared. New branch of maths. Log A times log B is not log AB. Yeah, please, or log A plus B. Or new branches of maths. That's the answer. Very good. Number 5. Integral x e power x squared dx. The moment I see this, straight away LATEC. So you got an A, you got an E. So u is x, dv by dx is e power x squared. Fine. Du by dx is 1, v is integral e power x squared dx, and I have come across students doing this. Maths is my grandfather's property. That's the reason, remember, e power x squared can never be integrated, because when you differentiate x squared, you don't get a constant. This is where, remember I told you the logic, don't blindly, even though I've been doing integration by parts, that question is what you call a red herring. So what's the first step? Can you integrate directly? You can't. Can you use substitution? What is the need for? How do you know when you can use substitution? You recognize a function and its derivative. When I differentiate x squared, I get 2x and I have an x. So remember, I'm going to use inspection. d by dx of x squared is 2x. So I need a 2x, so I'll write integral e power x squared times 2x dx. I introduce a 2, so I divide by a 2. Now, if you call u as x squared, it becomes e power u du. E power u gives you e power u, so it is half e power x squared plus, otherwise use u equal to x squared. I don't want to do it. You know the method of substitution, your teachers have taught you, I have gone over it, use it, you will get the same answer. I will stop at this stage. In the next one, or I'll just do one more question. My stopwatch has gone somewhere. Yeah, it's about 15 minutes, so I can do one more question. Integral x power 5 e power x squared dx. How will we do this? No information is given. I can't use LATEC. Why? I can't integrate e power x squared. But let's look at what do you get when you differentiate e power x squared. I get 2x, correct? X power 5, can I write it as x power 4 times x? So that x takes care of this. This one is actually x squared the squared. So I have a function and its derivative, so I can use substitution. Suppose you call t equal to x squared. What's dt by dx? 2x. So what is dx? dt over 2x. So it becomes integral x power 5, I don't know what it is, e power t dt over 2x. X and power 5 gives you power 4. So half integral x power 4 e power t dt. I cannot integrate because I have an x. If x squared is t, x power 4 will be, t square. So it becomes half integral t squared e power t dt. Now I can use integration by parts. Generally, if this question comes in the examination, use the substitution t equal to x squared and evaluate. Right? So, let's see. Okay? So, half integral t squared e power t dt. So, that is algebraic, that is exponential. So, u is t squared, dv by dt is e power t. du by dt is 2t, v is integral e power t dt, which is e power t. So, half integral t squared e power t dt equal to u v minus integral v du by dx. I still have two functions. I have to use integration by parts. Again, a word of caution. You got the 2t by differentiating u. Even in next integral, that has to be u. If you interchange them at that stage, when you simplify, you go back to the original question. So whenever you are applying integration by parts more than once, be consistent. Whatever was the answer for du by dx, that the u for the next integral. Whatever was the answer for v will be the dv by dx for the next integral. Okay? So don't forget. So therefore, for this one, u equals 2t, du by dt is 2, v equals e power, dv by dt is e power t, v is also e power t. Where shall I write now? I'll write there. So therefore, question becomes half, oh, I forgot the half here. So half e power t squared minus u is to t e power t minus integral e power t times 2 dt. So that is a half e power t squared minus t e power t plus e power t. So now go back and write it. It will be half e power t times t squared minus 2t plus 2. Yeah. So that is half e power x squared times x power 4 minus 2x squared plus 2 plus c. So sometimes the question looks impossible. You have to use substitution and then use integration by part. That's a very nice question. So I will stop at that stage because it's 20 minutes exact. I'll see you in the next lesson. I'll do a few more questions on integration by parts. Bye-bye. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded, and launched. Thank you very much.